While the Cold War between the United States of America and the Soviet Union led to many destructions, it was at the same time a moment of great engineering marvels. Both countries understood the power of technology in future wars and rivalry. Keeping this in view, both struggled to produce the most efficient weapons, warfare, missiles, and of course planes. This was paired with the founding of remarkable aircraft, which can travel up into space, betraying the radar and security systems of the opposite country, and collect the important information and data about the land and operations going on in there. X-15 is among one of the most appreciated inventions of its time. It was the first ever plane that was capable of crossing the hypersonic dominion, and which can travel into space as high as 100 kilometers from above the surface of the Earth. The manufacturing of this plane later helped NASA to understand the risks and security concerns needed to survive in space. Pressure control and vacuum survival techniques allow bringing forward the perfect spacesuit for the plane pilots. It later helped create aircraft with supersonic flight capabilities. The Apollo project, Lockheed State Route 71 Blackbird, and the space missiles were followed by this amazing discovery. Even to this date, no aircraft has ever been able to cross the fastest speed of this X-15. In fact, the considerably most powerful State Route 17 has also lagged behind. The record of X-15, having the maximum speed of 6.7 Mach, which makes 7,200 km per hour, is still unbeatable. Whereas the maximum speed of State Route 17, which stands second to it, is just 3.529 km per hour, which is almost half that of X-15. This tremendously amazing aircraft was developed back in 1950, decades of modernization and advancements have passed, but still, no aircraft until today has been ever able to cross X-15, not in terms of maximum speed, nor in its maximum altitude. All of this achievement was because of the powerful engines X-15 was designed on, and the rocket propulsion technique that would give this aircraft its initial activation energy. The engines of X-15 are capable of creating an initial thrust of more than 240,000 Newton as an output. Moreover, it also possessed the capability to variate this energy, according to the needs of flight. As it is said, every problem comes with so many challenges, and every challenge solves so many problems. The ability of the plane to cross the sound barriers and achieve the variable speed required it to have several spare engines and chambers. However, adding a lot of combustion chambers was also adding more weight to the aircraft, halting its ability to achieve high altitudes. This challenge helped the engineers to modify the turbopump in the engine. As the pump would induce less pressure on the fueling and oxidizing chambers, releasing them all together in the combustion cell, there will be lower fuel supply, and hence lower speed. As the pressure will increases, more combustion activity will take place in the cell, ultimately increasing the speed of the aircraft. This was not as simple to achieve as it is said. A big chunk of X-15's weight was just the fuel for its propulsion, that is 8,165 kilograms only for an 85-second flight. That means around 5,900 kilograms of fuel were burnt just to achieve 1-minute flight. To achieve it, a strong pump was needed, which ultimately needed a strong energy source. So, a completely new fuel was introduced to make this happen. It was a monopropellant that included a well-measured amount of hydrogen peroxide. The fuel burning resulted in a highly exothermic reaction. As this hydrogen peroxide fuel would pass through the silver catalyst-coated plate, it would convert into the water in the form of steam, with a temperature as high as 737 degrees Celsius. The explosion of this steam from the tail of the plane helped it move around in the air and space. The valves in the turbopump are used to control the amount of hydrogen peroxide fuel passing through the silver plate, converting it into a measurable amount of steam, and thus control the speed of the aircraft. Moreover, to give the pilot more control of the aircraft's direction in space, thrusters were fitted on the wings and nose of the plane. These thrusters also used hydrogen peroxide as fuel. The next challenge to create this craft was to find the right fuel that can allow the achievement of a specific impulse required by the plane to go beyond hypersonic regime. Although hydrogen was the most efficient fuel in terms of its lowest molecular weight, there were many other problems faced by this. First of all, it needed large volume containers to be stored, and secondly, it could seep out easily from the storage unit, threatening the explosion of the whole craft. The fuel used at that time was an alcohol-water mixture. The added 25% of the water was necessary to keep the temperature of the engine cool. However, it was at the same time reducing the engine's impulse, which was only 269 seconds. It was too small as compared to the required efficiency of this aircraft. The first challenge of keeping the engine cool was achieved by passing the unburned fuel through the metal pipes. This moving fluid would keep the metal cool and thus safe from melting. This process was known as regenerative cooling. After experimenting with different fluids, anhydrous ammonia was found to be the perfect match for this purpose. This anhydrous ammonia also has a high latent heat of vaporization, as well as high heat capacity. Thus, it was the ideal fuel any aircraft or rocket can ever have. This amazing conclusion was also derived at the time of manufacturing of X-15. All these experiments and discoveries helped the achievement of modern aircraft of today, and are still in use. However, the competitor of X-15 is still non-existent. It remains on the top.